In this video, we will continue our discussion of polar coordinates by looking at polar representations of curves. But to begin with a recap, up to this point, we've typically thought of a point in the plane as having coordinates x, y. And recall what those things measure. Y is this directed distance from the x-axis, and x is the directed distance from the y-axis. Instead, with polar coordinates, what we do is we measure a point's location in terms of r and theta, where r represents the distance away from the origin, and theta is corresponding to this angle formed with this formerly positive x-axis going in the counterclockwise direction. And recall the relationships between Cartesian and polar. X is equal to r cosine theta, y is equal to r sine theta. Just thinking in terms of some right triangle trig. Furthermore, by the Pythagorean identity, x squared plus y squared is equal to r squared. So let's put these three formulas to use. Let's graph the given Cartesian equation and then find the associated polar equation. X squared plus y squared equals 9. Purely by inspection, we hopefully recognize a circle of radius 3 centered at the origin. So roughly speaking, something that looks like this. Now, if we want to represent this in polar coordinates, we just need to observe. One thing we could, of course, do is replace x with r cosine theta, y with r sine theta. Because our conversions are x equals r cosine, y equals r sine. But additionally, we've seen that x squared plus y squared equals r squared. And this really is something we want to keep in mind. Whenever you see that x squared plus y squared, you want to replace it with r squared. So this becomes r squared equals 9. Or similarly, if we just take square roots, we can say r is equal to 3. And note, r equals 3 would represent all points 3 units away from the origin. So circle of radius 3 centered at the origin. R equals 1 would be a circle of radius 1 centered at the origin. R equals a positive number c would be a circle of radius c centered at the origin. Let's answer the same question for the equation x minus y equals 0. So to graph this, note that this is equivalent to y equals x. So this is the standard line that we would think of that passes through the origin with slope 1. So let's go ahead and represent this as a polar curve, and I'm going to do so in two different ways. So to begin, we're going to just plug in x is r cosine and y is r sine. So we have r cosine theta minus r sine theta is equal to 0. So r cosine theta equals r sine theta. If we divide the r's off from both sides and divide by cosine, what we are left with is 1 is equal to tangent of theta. And this does give us a perfectly good polar representation of the curve. But ideally, we would have something that's maybe a bit easier to work with. So let me make another observation that if we look at this angle formed, because it is the line y equals x, that's a 45-degree or pi over 4 radian angle. So if this angle is pi over 4, that would correspond to our theta value. So alternatively, another perfectly good equation for this line would be theta equals pi over 4. Now note, you may be looking at this and say, well, when theta equals pi over 4, we just get this upper portion of the line. But remember, this would correspond to positive r values, and if you had negative r values, that would correspond to the bottom half of the line as well. So let's kind of go in the opposite direction now. We're given an equation with a polar representation, and we would like to find the Cartesian representation of that equation. So very similar to our first example, except we need to manipulate a bit to get to that Cartesian equation. And recall that x is equal to r cosine theta, y is equal to r sine theta, and r squared is equal to x squared plus y squared. So what I would like to do in this example is, because I have an r equals 2, but r squared is more convenient to work with, let's just go ahead and square both sides. So if r is 2, that means r squared is 4. And r squared is x squared plus y squared. So as expected, r equals 2 gives us the Cartesian equation x squared plus y squared equals 4, which would be a circle of radius 2 centered at the origin. One more similar example. In this case, we'd like to find the Cartesian equation for the polar curve given by r equals 2 sine theta plus 2 cosine theta. And it never hurts to remind us, let's remember x is r cosine theta and y is r sine theta, with x squared plus y squared equals r squared. And if we look above, we know, gosh, if that was an r squared, we could conveniently rewrite it in terms of Cartesian equations. If there was an r with the sine and an r with the cosine, we could also rewrite that a bit more conveniently. So let's just go ahead and multiply both sides of the equation by r. The idea being, as long as you do the same thing to both sides, you get an equivalent equation. So r squared is equal to 2r sine theta plus 2r cosine theta. So x squared plus y squared is equal to 2y plus 2x. And if we're just looking for a Cartesian equation, we could certainly stop at this point and say that this is a Cartesian equation. But in this form, it's maybe not clear exactly what this Cartesian equation is, so let's take it a step further. We could subtract 2x from both sides, and we could subtract 2y from both sides. And when you see this x squared minus 2x with a blank, y squared minus 2y with a blank, hopefully that's suggesting to you that we could complete the square. So minus 2 divided by 2 would be 1. So if we put a plus 1, and if we put a plus 1 on the left, we should also put a plus 1 on the right, this would become x minus 1 squared. Similarly, minus 2 divided by 2 suggests we put a plus 1. So if we add in a plus 1 on the left, we need a plus 1 on the right. And then the y components would be y minus 1 quantity squared equals 2. And this gives us maybe a nicer equation, at least in terms of visualizing the curve. It will be a circle of radius square root 2, centered at the point 1, 1.